when you're doing these, you need to have a label. So we're dealing with the cholesterol. The first thing we're going to make is a dot plot. I want you to look at this table, and I want you to find the lowest amount and the highest amount silently so that everyone has a chance to actually look for that. All right, has everyone found the lowest amount?
Yes, sir.
And that is
40.
40, I agree. And the highest amount is?
95.
So our dot plot, which is basically a number line, is going to have to go between those two numbers, right? Okay. So when we do this, we have to start with 40, and what should we go up by to get to 180? I would say let's go by tens, and then it'll just rest between 180 and 190, okay? No, you had really good thinking. Okay, so 40, I'm going to skip a box so that we give room for 5 marks, right? So 40, go over 2 boxes, and 50. So 40 and then 50. Does everyone see how that's working?
Yep.
Okay, so my next 2 boxes, 60, 70, and I'm not going to keep doing these. You should be able to count by tens by now.
How is this going to look like? Is it going to be like a graph? I'll leave it this one.
Should have just enough room to get to 190 if you started right here. So again, it's just like a number line. So when you go through this data, here, I'll give you a second or two to finish out that number line, but it shouldn't take very long. When you go through this data, I'm going to place these as accurately as possible. So each box represents how much? Each box represents 5s. So that tells you what you have to do. So the very first one, I'm going to mark so that I can tell I've used that data. So this first 40 will be on that number line, right there. See that? Now I have another 40, so I have to go directly above it. Then I have 70. Should be pretty easy. 80. 45, so where's that going to go? Between the 40 and the 50. The 95 between the 90 and 100, and so on. So continue working, but I'm not going to continue verbalizing that because that should be very, very clear. Is that?
Bless you. I did. Nothing.
All right, how much more time do you need here?
Just a little.
All right. One extra thing that our dot plot needs. Do we know what these numbers mean?
No.
Well, we do. But would someone, if they looked at that data?
No.
What does that mean?
Cholesterol.
Okay, so we know it's fast food sandwiches cholesterol data. So the biggest problem is that cholesterol in milligrams is what we can label that. Cholesterol in milligrams. So far in your homework, things that should be really easy points: getting this title, labeling our data, drawing a number line with consistent scale, and then finally the data. Okay, it's time to move on. We have to go on to a histogram. And this is just a frequency histogram. So, our scale is already set up really nicely. We can go from 40 all the way to the edge of the paper, right? So, go down a little bit. You can see about how much I did. And label. So, we start with 40. And so on. Get your label set. What's up, JJ? Correct.
Remember as sandwiches on the side of the dot plot?
No, dot plots are known as just individual pieces of data. So it doesn't need an extra label. It's nice that you did, though. Okay, this is now still cholesterol in milligrams. And now, Logan, we do need frequency. So I'll put, I haven't counted how many we actually need, but I assume that should be enough. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. I believe 8 is the amount you need. So now, you make sure you label that this is frequency. What's that?
Nah, it's alright. Just put it up by there and it'll be good. And you'll know.
I would count you off for that on a homework, but if you know what you're doing right now, you do you.
I don't know. You can do every half plot instead.
You could go every half, that's right. So you could go by twos. 2, 4, 6, 8. Yeah, that was smart, Logan. Okay, so now, remember, this means between 40 and up to 50. So 40 through 49 is what goes in between these two boxes. What's our frequency between 40 and 49? I see 1, 2, 3, 4, 5, 6, 7, 8. So, right there. How many do I have from 50 to 59? 3. 60 to 69. 1. 70 to 79. 2. 80 to 89. 3. 90 to 99. Okay. And then finally, where's our last little piece of data?
60 to 70 was just 1, right?
Yes. It's up there, Bob. All right, so this is a frequency histogram. Now, we have to convert this to a relative frequency histogram. Can you tell how many total sandwiches we have?
Yeah.
How could you figure that out?
I can't read what that says at the very end. Something to something.
180 to 190? So, let's see, I have, hey, continue being focused right here. I have 8 and then 3, so I have 11, 14, 16, 19, 21, and 22. So we do have 22. What's up? Where? From 60 to 70, there is 1. Okay, I'll count that again. 8, 11, 12, 14, 17, 19, 20. Oh, it's just 20. I counted one of them twice. Very good.
You counted the ones.
Okay, so there are 20 total sandwiches, right? So I remember that. I'm gonna put that underneath the sandwiches so I can remember how many there are.
Sandwiches.
Okay, hey, we're getting close. We're about halfway point. We can make it. You can make it listening and focusing and still being able to work. Nope. That's great. Now, we have to convert this to relative frequency now. Relative frequency deals with percentages. What's the highest percentage I'm going to have to go up between? Between 40 and 50. And what percent is that going to be? 8 divided by 8 divided by 20. So that's 0.4. Because there's 20 total sandwiches. So we need to keep the same scale. So we have 0.05. I hope you're listening. 0.1, 0.15, 0.2, 0.25, 0.3, 0.35, and 0.4. Do you see how it's the same scale? I have 8 marks. Compared to this. I need you to be able to make that connection. So we're going to have to label this side relative frequency.
How many far do I have to go down to make it then?
8. And our scale on the x-axis is going to be the exact same. 40 to 50. and still have your label. Cholesterol in milligrams. Now, how do you think these are going to look compared to one another? Similar. We all agree? They're going to look similar?
By the way, you're supposed to move it over one because it's supposed to be 0, 40, 50, 60.
No. The 0 is the corner. This isn't normal graph.
It's fine. 40 is the
Okay. Right now, 40 is the corner. Logan, it might be referencing this. Some mathematicians like it when, if you're not starting at 0, you do this and do 40. I skipped that because it's irrelevant to us right now. This is a more professional way of expressing that information. Okay, so between 40 and 50, what percent do I have to go up to?
0.8. No, 0.4.
0.4. Do you see how it's going to be the exact same? Because we kept our scale as the same. 1 out of 8, or 1 out of 20 is 5%. 2 out of 20 is 10%. So we're going to go up to the exact same heights. Okay, so between 40 and 50, there are 8 sandwiches. And 8 divided by 20 is 0.4. 3 divided by 20 is 0.15. 1 divided by 20 is 0.05. 2 divided by 20 is 0.1. 3 divided by 20 is once again 0.15. 2 divided by 20 is again 0.1.
50 to 60 is lower than this.
No, it's not. It's the same. There. Now, all of that fits on one screen.
Yeah. That's pretty neat, Mr. Dusser. We got them in.
I mean, if you want, you don't have to. Okay. Now, the big idea of this last set of data was shapes of distributions, right? It says it at the title of each of those pages, shapes of distributions. So, we have been focusing on how to describe those shapes. What are the 3 things you have to describe that shape?
Shape, center.
Spread, shape, and center. Okay, now, what is the spread, guys?
It was that one of those shapes that you had drawn up there the other day.
The spread?
That's called shape.
The spread? The range. The range is the maximum minus the minimum. So what was our max sandwich? Do you remember?
185.
185 minus our minimum, which was?
40. 105.
It's for 145 milligrams of cholesterol. Okay. The shape. There are 3 different potential shapes, right? We have approximately normal.
Do you like black licorice?
No.
Hey, nope. There are no side comments, remember? The approximately normal looks like that bell, right? And then we have the skews. We have skew right. Skew right is where it tails off at the end. Skew left is where it tails off at the left. So for this spread of data, what do we have?
Skew right.
Skew right. I'm just going to circle it since I drew all three because I wanted this to function as notes for you. Okay, we haven't focused. Hey, side conversation right there. Please stop. We haven't focused much on center. That's what we're going to focus on this next investigation. So right now, this is an approximation. Where do you think the center of this data is? If we had to balance it all.
80 to 90.
80 to 90 right here?
Yep.
75. Wait, is that where the...
This is where we're saying our center is right now. We're not really caring what they are. Is this the balance point for all this data?
I think it's 50 to 60, 75.
All right, I've heard mostly 75 and 80. Let's say 80, just because that's the most I've heard out of all of you. So what you can think about here is that this is the balance point of your data. Hold on. You're going to have to replicate this for the CYU. This is the, check your understanding, page 83. This is your homework, which you're going to turn in. I'm giving you 20 minutes to do this. You are doing the dot plot, the histogram and relative frequency histogram, and describing it.
Can you go back down? I'm still drawing the stuff in the definition.
All right. Now, is there anything else that we're missing in our description here that you think would be important? I'm asking your judgment, your opinion here. What? The why?
You switch them around. It's skew left is the...
No, it's not. Logan, it's fine.
It's correct, Logan.
Okay.
It's correct. We defined that on the second page where skew right was tailed off to the right, skew left is tail off to the left.
That's weird.
It's describing where the lower points of those data are. Is there anything else that you think we could think to add? Okay. So, I'm going to pass out more of this graph paper so you can do your homework and turn it in class. Again, I'm going to give you 20